divided by the natural log of a, which is 2, and plus a constant. And now we can plug it in back this. So 1 over 48. In this case, I can write 2. Whatever u is, that was the natural log of x cubed divided by the natural log of 2 and plus a constant. You can't simplify that, just leave it like that. So we want to use u substitution to let us use this formula, and at the end we plug in back u to the general equation, and that will be the final answer. And because without u substitution, this would have been difficult to solve unless you use some program to solve it for you. And that's the answer. Any question on that? So this was a problem number 5 on page 448. And again, if you cover section 7.1, 7.2 of Math 65 or Calculus 1, they have these formula and they cover these. If you took it a long time ago, I don't assume that you should know this. I'm going to solve it for you just like this is your first time. So, any questions? Okay, so these are the formula. These are the type of question you're going to see. Anything on this section will be related to the page 448, one way or other way, and it will be like that. So something like this. So let's say integration of 1 to 2 of 8 over x squared minus 2x plus 2 and times dx. If you look at page 48, you're not going to find something for this. We have to make it look like some of the formula like that. Okay, if this was a perfect square, it would have been perfect one because we could have used inverse sine or use substitution or any other method. But this is not a perfect square. So we have to make it a perfect square. Once we have perfect square, then we can use any of the formula in there. So in order to do that, the numerator is okay. We can pull this outside. So let's find something with this one. So with this part, I'm going to take that x squared minus 2x plus 2. I'm going to make it a perfect square. So I'm going to write it in parentheses, minus 2x. I'm going to write this to other side of parentheses like that. Remember the completing the square? Let me say differently. So all you have to do, take the middle term, negative 2. You always divide that by 2. So the answer is negative 1. And you always square that. So it gives you 1. So that gives you plus 1 here. On the other side, you have to do the opposite. Remember, completing the square has 2 parts. If there was an equation equal sign, we put 1 here, 1 in there. But this is an expression. There's no equal sign. So you put the plus in here, the opposite of that, which is negative 1 on that side. So this part will be a perfect square. So that will be x squared minus 1 squared. So if you factor this, this will give you that. And this will give you a plus 1. So now this is something we will recognize. So this is 1 to 2. We have 8 in the numerator. Instead of this whole thing, I'm going to place that x. Should this be x? Sorry, not x. When you factor it, so that gives you. So this would be x minus 1 squared plus 1. Now you recognize this. This could be a u squared. This could be a squared. So the formula for that can apply as a tangent. So problem number 19 is formula number 19 on page 448 will apply to that. Okay, so our u is x minus 1 and x minus 1. So du will be just dx. It's 1 dx. And now we have to change the limit of that. So if you call this u, then we have to call this one as a limit. So this value, if x is 2 and u will be 2 minus 1 gives you 1. If x value is 1, so u will be 1 minus 1 gives you 0. So the limit of integration is 0 to 1 of 8 this whole thing is u squared plus 1 and times du. Now we recognize this is number 19 on your book, so you can pull this 8 outside. So this is 0 to 1 of 1 over n squared plus 1 times du. And this is the same as 8. The whole thing is the inverse tangent of u. So inverse tangent of u, and that goes from 0 to 1. So now we can apply that. And so we can pull 8 outside. The upper limits on the inverse tangent, you can use your calculator. So this would be inverse tangent of, of 1, yeah, upper limit is of 1 minus the inverse tangent of 0. So this will give you 8. Tangent is 1, that's going to be 45 degrees. And this is 0. So the answer is 8 divided by 4 gives you 2 pi. So that's the final answer. And so a lot of the formula in the beginning, it doesn't look like, but sometimes you cannot factor. Don't use quadratic formula, use completing the square because the one side, our goal is to have a perfect square. And then we can use the formula. Okay, so let me do another one by completing the square. So. Okay, so the integration of 7 divided by x, this is x minus 1, and the square root of x squared minus 2x minus 48 times dx. Okay, so this one is not a perfect square. You just leave this alone, and 7 is okay. I'm going to take the inside the square root on the side, and I'm trying to find it as a, so let's say this is x squared minus 2x minus 48. There's no equal sign, so this would be x squared minus 2x. Put that in the parentheses, move this away from the parentheses. So exact same sign. So do the same thing. You're going to take this number divided by 2, which gives you negative 1. You always square that. So that will be plus 1. And here you have to put the opposite of that. Now this will give you perfect square. And that's the same as x minus 1 squared. This one gives you 49, which is perfect square also. So now this whole thing, we have perfect square on both sides. So this is integration of 7 over x minus 1 multiplied by the square root of, this would be x minus 1 squared minus 49 and times dx. Now, if you look at the formula, this is the formula for inverse secant. So this will be number 20 of your on formula on page 448. Is number 20 applies to this. So I'm going to pull that 7 outside. So let's first of all recognize. So we can use a u substitution will be a lot easier before we make it complicated. So u will be x minus 1, and du will be just equals to dx. So if I factor this outside, integrations, I'm going to put 1 there. This looks like it's my u value. And in the square root, this is a u squared. And okay, so this would be a squared is 49. And a is plus 7. It would be 7. Square root of that gives you 7. So this would be 7 squared. So same thing. Okay, so now we have this, and this is times du. So we can apply that. So the formula for that, 7 will stay outside. So this would be 1 over a multiplied by secant inverse of u over a plus a constant. So you have everything to plug in. So you have 7 here. This is 1 over 7 because that. And this will be secant inverse. U is x minus 1. A is 7 plus the constant. And this cancels with that. So the final answer is right there. So a little bit of algebra involved, but the rest is all doable and very simple. I'm going to give you a few problems for you to do it, then we'll start the next section. So remember, after this section, most of the integration, not all of it, most of it, you're going to have seen new. So this was just the last part. They want to review everything that you learned in this class, in the previous class. So let me give you some formula to do 2 problems. I'm going to give you, let's see. Okay. So I'll give you 2 problems to solve. So first one, I will ask you to do this. 2 to the power of square root of y over 2 times square root of y and this dy. And the second one, I'll also find okay, so this is also a good one. So 1, 2, 3, 4x squared minus 7, 2x plus 3, and times dx. So both of these are kind of hard, but just it's a practice. So yeah. One thing I can, this is a formula, the one number 5. This one, you have to use the long division. Remember, if the power are exactly the same, use the long division. If the power of the numerator is only 1 degree higher, then you also use long division. So if this is higher, power is higher in the numerator, use the long division, or if they're exactly the same, use the long division. So for this one, use long division. So go ahead, solve this, and I will help you with both of them if you. I'll give you the answer with the but I'll solve you step by step. So the answer to this one is and the answer to this one, let me see. Those answers in the back of the books I have. The second one, I did the long division and I set it up to this point. So now this is easy. For this one, you can use U substitution. It should be okay. And the rest is just all plug it in. And I think it has limit. Yeah. So this was 1, 2, 3.